Hello, good morning all. Myself Parthiv Radharia and my ID number is 22DC097. So I am going to explain you the pseudocode for clustering algorithm. So here we have taken data samples as x1, x2, x3 till xn and clustering points as initialized k-means is x1, x2 till xn. So now for all n minus k sample, we will find the minimum distance using distance formula. Once the minimum distance has been found out, we will update the minimum distance into the respective cluster points. Then we will find the mean values. So once the mean value has been found, we will update it according to the cluster point into initialized k-means. So we will get the new cluster points. We will repeatable now the next step is repeatable loops until no update in center data point. So we will now again follow the same procedure. This procedure will be followed again till we will get the same mean values as the previous one. Then we will have to stop down. So the main of the K-mean clustering algorithm is first we can see in first graph that all the points are differently scattered in the x and y axis. So after applying this algorithm, you can see that the points has been grouped into the different parts. Now, my friend, they will continue to explain you the hierarchical clustering algorithm.
Hello everyone, my name is Raide. My ID number is 22DC100. Today I explain the hierarchical clustering algorithm. So what is hierarchical clustering? Hierarchical clustering is mainly the tree-like structure and it is known as the endogram. There are two types of hierarchical clustering, top-down approach and bottom-up approach. Bottom-up approach is known as agglometrics. In this method we can merge all the data point together, and second one is divisive. In this, one bigger data point is considered and then other further it is divided into small cluster. So first turn each input element into a singleton into a cluster of a single element. First we can plot data point into graph, then after we create a matrix using this data point, and we can find the distance between all the data point using different distance method. Then after we can plot matrix, and in this matrix we can plot the different distance between two data points. Then after we can there are three methods: single link, complete link, and average link. In these three methods we can find minimum distance from this matrix, and then we can merge this that two data point and create the dendrogram using that two data point. Then after we can create then after we can find the distance between these two combined data point and other data point, and repeat this process until the entire dendrogram is created. Then after we can see here this type of dendrogram or the graph is created at the last time. So we can find the we can find the clustering using hierarchical. Now my friend Harshil will explain the different distance method.
Hello everyone, my name is Harshil Rohela. ID number is 22DC101. The first distance method is Euclidean distance. The measure which gives the distance between any two points in n-dimensional is known as Euclidean distance. Euclidean distance is basically the length of a line segment between two points. The formula for which the Euclidean distance in two-dimensional, for that we have get 2 points. Is first is x1 y1 and second point is x2 y2. The formula is d equals to under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. For three-dimensional, it is same as the for two-dimensional. Only the z coordinate will be there, which is z2 minus z1 the whole square. Now the second distance formula is the Manhattan distance. The Manhattan distance is the distance between the two vectors, which is equal to the one norm of the distance between the two vectors. The distance function include is known as the taxi cab matrix. The formula for this is the sum of absolute difference between the points. For example, we will get first point is A, B, and C, and second point is X, Y, and Z. Then the Manhattan distance between these 2 points is the absolute value of a minus x plus absolute value of b minus y plus absolute value of c minus z. Then the third technique is Minkowski's distance. It is the distance measured between 2 points in n-dimensional. It is basically a generalization of Euclidean distance and Manhattan distance. It is used in algorithms like k nearest distance. Then second is a learning vector quantization, self-organization map, and k-mean clustering also. The formula for this is two-dimensional. For this, we have 3 points, x1, y1, x2, y2, and x3, y3. The formula for the distance is the absolute value of x1, y1 into p plus x2, y2 into p plus x3, y3 into p whole raised to power 1 by p. Here the p is the number of points. For the example, the p will be here is 3. Then the third technique is cosine similarity. Cosine similarity is a matrix helpful for determining how similar the data objects are respective to their size. We can measure the similarities between the two sentences in a Python using cosine similarity. The formula for the cosine similarity is the first is x comma y equals to x into y division by absolute value of mode of x into mode of y. Then the last will be the Hamming distance. Hamming distance. Hamming distance is a matrix for comparing the two binary data strings. While comparing the two binary data strings of equal length, Hamming distance is the number of bit points in which the two bits are different. The Hamming distance for 2 points, for example, A and B is denoted as D of A comma B. It is used in error detection when the data is transmitted over the computer networks. It is also used in coding theories for comparing the equal length of the two data words. The formula for this is we will perform the XOR operations of the two strings A XOR B and then count the total number of ones in the resultant strings. These are the 5 different techniques for the distant techniques. Thank you.
And these all distance techniques are used in the both the algorithms that me and Gay has explained. Thank you.
Thank you, everyone.